Let's graph this rational function. So we're going to find the intercepts and asymptotes, and hopefully that's enough for the graph. If not, we're going to have to find some additional points. But let's start with intercepts. X-intercept. That happens where y equals 0, or in other words, where the top of this fraction equals 0. So let's factor the top. X plus 5, x minus 3 will do it. So x-intercepts are where the top equals 0, or where x plus 5 times x minus 3 equals 0. You can see when you have it factored, that's a very, very simple thing to do. So I have my x-intercepts, -5 and +3. Very simple. Y-intercepts. Y-intercepts, you're going to plug in 0 for x. So basically, I'm going to plug in 0. And do this on the non-factored version. It's a lot easier. 0, 0, 0. The y-intercept will be y equals -15/4. I'm going to think of that as a decimal, or 4 goes into 15 3 times and 3/4. Just so when I go to graph it, that's how I'm going to think of it. Easier to graph it. So that's that. I guess they call that a mixed fraction. I don't know. All right, so asymptotes. Vertical asymptote is where the bottom equals 0, where this fraction is undefined. So the bottom is x plus 4. Obviously, that equals 0 at x equals -4. Horizontal asymptote. Well, the degree of the top is bigger than the bottom, so there is no horizontal asymptote. Slant asymptote. If the degree of the top is exactly 1 bigger than the bottom, so the top degree is 2, the bottom degree is 1, 2, 1. So this has a slant asymptote. To get the slant asymptote, you divide, and you ignore the remainder. So since this is a setup for synthetic division, because you're dividing by x plus 4, you can do this with synthetic division. 1, 2, -15. So bring down the 1, multiply -4, -2. This will produce remainder, so I don't care about it. We ignore the remainder. So the slant asymptote is at y equals x minus 2. Make sure you present it as an equation, y equals mx plus b, the same way you're presenting the vertical asymptote as an equation, x equals -4. So here we go with the graph. Hopefully that's enough to get a good idea of what the graph looks like. The x-intercepts are -5 and 3, or -5, 0, 3, 0. And they have multiplicities of 1, so the graph will go through them. The y-intercept is 0, -3 and 3/4. Again, the only reason I'm doing it with a mixed number here is because it's just easier to see. -1, 2, 3, and 3/4 down here. It has a vertical asymptote at x equals -4. And then a slant asymptote at y equals x minus 2. So you have to remember how to graph a line. The y-intercept is -2, b, and from there you go up 1/1. That's easy. And it's an asymptote. So a slant asymptote is just a horizontal asymptote that's slanted. It's so you can treat it just like a horizontal asymptote. You graph this, start on the very left of your slant or horizontal asymptote and start graphing it based off all the other points. So I know for a fact that the graph is going to approach the slant asymptote on on both sides here. So I'm going to start from the left. Um, I, I have to either go straight up or straight down on this vertical asymptote right here. And you can see I have a point to go through, this x-intercept. So it has to look like this. This is not kind of an awkward graph, but that's it. It has to approach the slant asymptote on the left the same way it approaches a horizontal asymptote on the left. And then it has to you go straight up or straight down to the um, vertical asymptotes. So that's part one of my graph. And remember, there's two parts to this graph because there's one vertical asymptote. You need to uh, have one piece of the graph on each part of the vertical asymptote. So I have one more piece left to go. So I go to the right over here of this asymptote, and you can see I have to go through this point and this point. So I really have to start like this. And then since I have a vertical asymptote here, I'm going to have to just keep going down and approach it. It goes down without bound here to the vertical asymptote like always. And that's all there is to it. That's the graph. So if you really think about this, it's just as simple as if that slant asymptote was a horizontal asymptote, because it's just the same thing as a horizontal asymptote. The only difference is it's on a slant. But other than that, that's it. So you should check this on your graphing calculator. And that's all there is to it.